Hello, hello, CNG 124. Welcome to Monday of week 5. I had some questions last week about the cables and it came up twice. Make sure you just take a detailed, or I shouldn't say a detailed, but many detailed pictures about your Lab 4 and then submit it in the Lab 4 UTP cables. This is probably one of the uh, people. So when I teach a class in face to face, it's the same, almost the exact same way it happens. Um, people don't get binary math week one. You know, they drop the course, and I always say this class is going to be tough because you're thinking in different ways. And if I knew how to um, deploy this course in a different way, and the way that would help you guys the most, I would change it, but this way is the best that I have so far. Um, and it's what I get the least amount of drops. So usually people always drop this class all the way up till they're building cables this week and doing punch down panels in the face-to-face course. But if you've made it this far, I repeat, do not drop the course. If you're kind of getting it, or if you still don't get it, just keep practicing because you will get it. Um, and that's just the way it is. We're thinking in different math languages, and then we're taking those and applying those to something else. But as the same with UTP cables, I've had students just get frustrated that they couldn't build cables and just quit. But once again, you know, if you're not a baker, don't expect to bake a cake on the first try. Expect to bake a cake, 2, 3 tries out. The same with cabling. You're not going to be a professional the first time you make one, and I don't expect you to be a professional. But that's why I'm going to give you feedback, and you have a little kit so you can keep on testing yourself and using these the tools that you have to make it easier for you. One of my first jobs when I was in school was an intern at a cabling company, and pretty much they stuck me in a what was it? It's over 65 units. 65 units. Some were studios, some were 3 bedrooms. But I was in there just terminating cables. I'd go in with my headphones. I'd have to wear boots, but I wore boots and shorts, and just kind of went in with my headphones and sat at the cabling closet and just took off from there. Spent 40 hours a week. I think I worked actually more than that, some overtime. But that's all I did every day for a week. And then once my fingers hurt, but I got really good at it and could do it really effectively. And you know what? I kind of liked being left alone and just listening to music all day. It was a good job for me. This week, week 5, we jump into what is it? Number of bits to borrows. Okay, so we're looking at calculating subnet masks. Um, as we've seen for IPv4 class full, A, B, or C, um, we have just stuck with the basic, um, the default subnet masks. At this point, we're going to start to borrow bits and start to calculate subnet mask to borrow. Now, this is real important, especially this week, that you practice first before trying to jump into the lab. So when you go into the page 7 and 15, okay. So let's go to page 7 and 15. It's up here. This video is going to be kind of longer because it's going to take. We're doing a lot different things than usual. Um, 3, 4, 5, 6, 7. Okay, there's 7. So these are the default subnet masks. Once again, you're given an IP, determine A, B, or C, and then write the default. When we go to 15, actually, I guess you can start here, really. When you start on page 12, um, you look at the number of subnets needed, the number of usable hosts needed, and the network address. So we're going to see we're going to need 14 usable hosts. We're going to need 14 subnets. First thing we got to do though, number 1 is what kind of address is it? Identify as a class C 192. Okay, Okay, kind of right there. 192 Class C, we know the default 255, 255, 2550, but we need to customize this so it fits as close as we can to 1414. So we're going to do some math down here, and as if you go down here, we're in this octet, we're in this last octet, so 192, 10, 10, and then zeros, so we're in our last octet. Then we're going to start to figure out where do we have to go to get to a place where we have 14 usable hosts. So if we start clear out here at the default, we see we have 256 hosts, can't use the first or last, so therefore we have 254. If we move in one, we have 128. Again, if you minus 2, you 126. These are very large. These do fit 14 usable hosts, but we can just keep on going down. Let's see, 64, it'll still fit. 32 to fit. 16, it'll fit very nicely. 8, it will not fit. So let's go back. Oops, I was in the wrong place. 16 usable hosts. I'm sorry, went too far and I was looking at the wrong line. Let me explain that again. So let's go back. Even though I was counting down in a different way of number of subnets, it still works in the same amount, but just slightly different. If we were to put 255, 255, 255, and then 255, we'd be out here and have actually zero number of hosts because you can't use 2 because first and last are always used. If we moved here to 252, we have 4 hosts, which if you use 2, you have 2. So if we go to 248, we have 8 hosts. And then 240, we then have 16 hosts. And we look at that number and say, hey, that fits really, really well. Is that the same answer as what they've given? They actually went one more over, which is okay. You can do it either way. But look at my video. I explain this in a different sense where I don't do it the Cisco way. But either way will work. But if you choose to go with this area here, you'll be borrowing 1, 2, 3, 4, 5 bits. So we borrow 5 bits. We have 16 hosts, 32 subnets, and then we have an 8-bit, or we have an 8 binary value, which is basically just saying this one, this one, this one, this one, and this one. As you see, 128, 64, 32. All of our bits we add up. So we add 128 plus 62, 192, plus 32, that's 224. Plus this one would be 240, plus 8 would be 248. So for mine, I would have the answer of total number of subnets, 32, total number of hosts, 16, number of usable addresses, 16 minus 2, since I can't use the first or last, is 4. Number of bits borrowed, I borrowed 5, and that is my answer for that one. Once again, you can either do it their way or my way. They both work, but whatever way works easiest for you. And again, you can use more practice. Here we are on page 13, done for you. You can see that they do the class address as a B. They do the default subnet mask. Since they only need 60 usable hosts, they got to go from the 3rd octet to the 4th octet, and that doesn't work so well on PDF, but they got to go to the 4th octet to get down to 60 usable hosts, which 64 is good, and then you'll have to fill this in with 255s because we're going to use every one of these. And then we're going to use 3 of these. And so when they say bits borrowed, you're going to say 8, 9, 10, 11. That's doing it my way. If you're doing it the Cisco way, remember you're going to borrow 10 bits and you're going to end up in this column here. Once again, This is going to take practice, so make sure you start on page 15. You start on page 15 and practice before you complete the assignment, or practice before you do the assignments, so that way you're not trying to do the assignment 3 or 4 times. And just to take a quick look at that, table of contents, week 5 assignments. So with Lab 6 Subnetting 1, basically I think we just work with Class C's to begin with, and it kind of gives you a too good of a hint at the top. At some point I'll need to take that out. But we're taking Class C addresses, and this is your first hint right there. Students will practice basic Class C subnetting. So what kind of type of address is it? Well, I just told you what kind of class is it. So then we just need to figure out how to divide this up. So remember, I'm giving you a 0/24. That means that if you think about those slides that we saw 2 weeks ago with prefixes, a class C/24 means you have all 256 addresses. And this is where we really start looking at those prefixes and saying, okay, what is going on in this subnet? How is the subnet divided up? And once again, drawing out the 8 dashes, since you know the subnet mask relates to the network address, drawing out those 8 dashes is going to mean a lot. And I think I have that in the homework video. Well, more than positive, I have it in the homework video. So as you look through this, and when you get down here, realize that the IP network addresses they don't start over again from 0 to whatever, but they work kind of like your gas gauge. They keep incrementing. So as you use 0 and then you go to a number here, this broadcast address is going to be one less than this network address. So it's just going to keep on counting over and over. Well, I shouldn't say over and over. It's just going to keep on counting as you get through these examples. And in some cases, you're going to end up at your very last usable or very last address, which is your broadcast address of that subnet. Sometimes you'll stop early. Sometimes you go past that. But once again, like your mileage, when you get up to 9 on your gas gauge, the 9 flips over into a 0, but then there's a 10th digit that's counted and added to that 10th area, and that's just like subnetting. Once that octet reaches 255, the left octet of that is incremented 1, and then it bounces back to the 4th octet or 3rd octet, whatever, and then it bounces back to the original octet and starts counting again until it reaches where it's supposed to, and then either stops or increments on the left octet again and keeps going. I do that to you a few times, so just be prepared to read to count like that. It's not difficult. But yeah, have a stab at this. There are going to be lots of questions this week. There's going to be even more feedbacks on this. As you turn them, we'll take this week just a little differently. As you turn in this lab, I'll be sending you back feedback because I want to make sure you practice this a lot because we're going to do this for a few labs just to make sure everybody has it. So this week I'll do some grading, and then when I see these start coming in, I'll also be punching those out in grades as well. Remember not to send the cables to me. Just make sure you take photos of the cables and submit them in. Looks like a few have a few in lab 4. Get those in there, and then I'll go ahead and grade them and give you feedback on them. Like I said, if I say do it again, take the time and do it again. Everybody could use network cable in their house, whether it goes from your modem to your router or your PC to your modem. Cable is relatively cheap, and if we open up a Amazon Cat5, I think we can go for 100 feet. I'll show you the difference here too. So here we have Cat5, 100 feet. This is already terminated, but say you didn't need 100 feet. It's going for $15. If you go Cat5, you can get 1,000 feet. I think for $70.